So let us solve example. A car starting from rest accelerates uniformly at 2 meter per second square. So here acceleration is given 2 meter per second square and it is starting. So initial position you can say u is 0 or x is equal to 0. Fine. X is equal to 0. For 5 seconds, you can say t1 is equal to 5 seconds. So a1 is 2 meter per second. Then moves with constant speed. Here velocity is constant, therefore acceleration is 0 for the next 5 seconds, and then come to the rest. Retardation is given. So a3 is equal to minus 2 meter per second. Draw position time graph, velocity time graph, and acceleration time graph. Good. See, when these graphs are asked, I simply suggest that start with start with acceleration graph. Start with acceleration graph. So first is that acceleration is positive is given for the first a1 for the past one part 1 we can say a1. Acceleration is positive and constant. Acceleration is positive and constant. So see, velocity is also positive, so that means what? Velocity increases. Velocity increases. Velocity increases. Then acceleration is 0 for the second case. Second part, acceleration is 0. Velocity is constant. And the third part, velocity decreases. Sorry, acceleration decreases. Acceleration decreases, and velocity linearly decreases. Fine. So what it means that if you draw acceleration versus time, right? So for the first 5 seconds, and then we can have next 5 seconds, and then after, right? So for the first 5 seconds, acceleration is given 2 meter per second. So from there, if you draw a graph, so for the first 5 seconds, it is having acceleration is equal to 2 meter per second square. Then it is velocity is uniform constant, so it is 0. So it should be like that. Passes directly through directly. So here acceleration is equal to 0. Then acceleration become negative. So here negative minus 2 meter per second square, and then continue. Fine. So here this is the case. Now if we want to draw, then next from this graph, from the first graph, we can draw acceleration graph. Acceleration is already there. We should draw velocity versus time graph. So in the case of, let's draw here velocity versus time at 5 and at 5 plus 5, 10. You can write here at 5 plus 5, which is 10. So here, first case for the first part, velocity is a positive, yes. Acceleration is positive, and it is starting from zero. It is starting from zero. So velocity start from zero. Velocity is positive, acceleration is positive up to this point. So here it gives linear straight line. Velocity is positive, acceleration is constant. So therefore our line is a straight line. Our line is a straight line. You can reverse also, you may check. You may check reverse also. You may check in the reverse direction also. Then from that acceleration is 0, velocity should be constant. So you can go velocity constant. And then acceleration is negative, velocity is positive. That means there is a decrease. There is a decrease in the velocity. So velocity is positive, acceleration is positive for the first case, right? Slope should be positive. Slope should be positive. This theta should be positive. Second part, velocity is positive, constant, so x is linearly increasing. Then velocity is negative concave shape. Fine. So let's erase this and again understand. So see here in the first graph, acceleration versus t. For the first part, acceleration is equal to 2. So acceleration is 2. Then it become acceleration becomes 0. Constant speed acceleration becomes 0. And then acceleration become minus 2 negative. Right. Now from this diagram, for the first part, here acceleration is positive and velocity is also positive. So when velocity and acceleration both are positive, we know that velocity increases in a straight line. And here acceleration is constant, therefore this VT graph is straight line. So what happened? Velocity is starting from 0 and reaches to, how to identify 10 meter per second. So area below A line, area is equal to 2 multiplied by 5, it gives 10, it gives 10 meter per second, and that gives velocity. Here velocity is equal to A cross T. From this graph you can just find 2 multiplied by 5, so it gives velocity. So it is 10 meter per second, therefore it is 10 meter per second. Then velocity is constant, then acceleration is constant, therefore velocity is constant. So from point 5 to 10, 5 to 10 velocity, it is constant. So constant velocity. Then here, if you go here, so velocity is positive and acceleration is negative. Velocity is positive, acceleration is negative. That means velocity decreases. Velocity decreases. Velocity decreases. Here it is decreased velocity. We are calculating decreased velocity going in the downward direction. So this is the graph. Right. So this is, we start from acceleration graph, acceleration t graph, and next you should draw velocity t graph, and then next is position, next is position, next is position, next is position. So in the position graph, first we will see this slope. Is it positive? Theta is less than 90 degree. Yes, so positive. So in the case of displacement, or you can say position time graph, in the case of position time graph, right? Slope for the first portion, should be slope of the first portion should be positive, or you can say less than 90 degree. Second is that see here, for the first portion acceleration is positive. So we know that if there is a acceleration is positive, our shape should be convex or concave. Shape should be this. Shape should be this. And theta should be less than 90 degree. Where it happened? Where it happened? Where it happened? Where it happened? If we take this angle, this is this angle, then only it is 90 degree. So that means this portion is required. So start from zero, it moves. Starting from zero, it moves like that, like that, like that, and up to S. S. How to find S? How to find S? How to find S? Yeah, area. 1 by 2, 1 by 2, 10 multiplied by 5. Because it is triangle, so 1 by 2, so it is 25, 25, 25, 25, 25, 25, 25. Then what next? See, slope is constant, velocity is constant. So for ST line should be straight line. ST line should have a straight line. ST line should have a straight line. Again, you can find this area, same area. How can you find area? We can find area by using this. This is 10 multiplied by 5. So 50, 50, 50 plus. We need to add the previous also. We need to add previous. So 25 plus 50, it gives us 75. It gives us 75. Right? So 25 plus 75, 25 plus 75. So this is just an area for this section. But whatever distance traveled previously, that we need to add. So 25. And here velocity is constant, so slope is straight. Slope is straight. Then for the last portion here, velocity is positive, but acceleration is negative. So for the negative acceleration, we have shape, convex, convex, and convex. And if velocity is positive, theta should be less than 90 degree. So which side is required? See this side. If you do this, theta is less than 90 degree. Therefore, this graph is required. So this graph, isn't it very simple? It is actually right. And similar here, if you wanted to have area 75 plus this is area 1 by 2, height 10, and that may be 5 multiplied by 5. Right? So we can again 25, 75 plus 100, you can get your answer. So let's start example number 6. If acceleration of a body is 0, here it is given acceleration is equal to 0. Great. Then if the velocity of the body is v0 and it starts from origin, that means u is equal to 0, then if t is equal to 0, x is equal to x0. So there are different conditions are given. Let's go for the first condition. Acceleration is equal to 0. So we know that acceleration versus time graph, if you draw, this is time axis, this is acceleration axis. And if acceleration is equal to 0, so what are we going to get here? This acceleration graph, it is like that. This is the acceleration graph versus time. If acceleration is equal to 0, that means if you draw velocity versus time, right? So here it should be a constant. There is no increase of velocity, there is no decrease of velocity. If acceleration is 0, so graph should be like that. Graph should be like the straight line, right? Then if you draw graph distance versus time, distance versus time. So here, if velocity is constant, distance versus time, it should be inclined line. That we know it very well. Right? So here it is given acceleration is equal to 0. So velocity constant, st graph should be linear. That we already drawn. So here this is our st gram and this is v and v0. That is that given velocity, it is given v0. So we can draw like that. Then in the second case, so first case is done. This is case number 1. In the second case, if t is equal to 0, and x is equal to x0. So in the x0, in the first case, x was started with 0 position, origin position, and it is mentioned here start from the origin. But in the second case, it is mentioned that x start from positive x0. Otherwise, all other things are similar. Graph is at inclined line. V0 will start from the same position, but this graph changes and starts from x0. So this is number 2. This is number 2. In the same case, in the same acceleration 0, at t is equal to 0, if x is negative x0. So what should be answer? Yes, you are correct. This graph should start from negative x0. Graph should start from negative x 0. All other conditions are similar. There is no change in the other condition. So it should start from negative. From negative. Right. So draw VT and ST graph. So these are the VT and ST graph. Here in all the graphs, first this common thing is that acceleration is equal to 0. Velocity is constant. Velocity is constant. Right. And x is proportional to t. X is proportional to t. Example number 7, a body has constant acceleration. So it is mentioned here. Let's first draw acceleration versus time. So body has constant acceleration. This is the acceleration. It is constant. One condition is given u0, x0 and a0 are positive. Means x0 is positive, u0 is positive, a0 is positive. Right? All are positive. And we need to draw position graph as well as velocity graph. So if see there is a you can see here acceleration is positive. Acceleration is positive. So what should be graph for the v and t? See if this is a straight line, that means velocity and t graph should have inclined line. Velocity and t graph should have inclined line. That is for sure. So this is velocity. This is acceleration, and it's starting with u0. And all are positive. All are positive. So positive side. Fine. Then third graph, if you go with S T graph, so we have to just check. We have to just check here. Acceleration is positive, hence it gives which shape? It gives which shape? Acceleration is positive. It gives concave. So this is the shape. This is the shape. This is shape. But we need to again identify. So angle, it is theta is less than 90 degree. So similar, the graph should be positive. Graph should be positive. If you draw tangent on this side, this is theta less than 90 degrees. So this graph should work. This graph should work. So our answer should be like that. Starting from this, velocity, acceleration is positive. Velocity is also positive. So velocity increases in positive direction. So here this should be the graph. Let's see here. Initial positions are positive u0, positive a0, positive x0. Fine. A is positive constant, so v is linearly increasing. That we already did in this graph. A plus, so it gives concave shape, and theta is less than 90 degree. Theta is less than 90 degree. We have checked. So solution is here. A0, it is here. Then slope a0. Then see it is given u0. So you just need to shift this body at some distance u0. So this is our correct answer for that. So velocity is, this one is the correct drawing. Then what is mentioned here for that? The graph, it is concave. Graph is concave, and this angle should be less than 90, means positive, and this graph starts from x0, so it should be at some upper side. The similar graph is just moved, right? So our answer is 1. This is, we can say, 3 and 5 are our solution. 5 are our solution. We have here example number 8. It is somewhat similar to the example number 7. You may pause the video here and you may try by yourself. That's all. If a body has constant acceleration, so acceleration is constant, u0 and x0 are positive. So initial velocity u0, initial velocity, and initial distance x0 both are positive, and a is negative. A is negative. Acceleration is negative and constant. Fine. So it is given here. It is given here. Let's solve this problem. So when we talk about initial position, initial velocity is positive, initial acceleration is negative, and the distance, initial distance is positive. Fine. So what starting with VT graph, let's start with graph. First, acceleration versus time graph. First, we are drawing acceleration versus time graph. So what is given here? Here it is given acceleration is negative and constant. So for the constant is straight line and acceleration is negative. Acceleration is negative. Now next is if we draw second, if we draw velocity versus time. Velocity versus time. So see, acceleration is constant. Acceleration is constant and initial velocity is positive. Initial velocity is positive. So what it gives? If any one sign is negative, that means velocity linearly decreases. Velocity linearly decreases. So initially velocity v0 is given here positive. Say for example, it is v0, and then linearly decreasing. So you can see here this kind of slope for the VT graph. For the VT graph, it crosses like 0 and then it goes in opposite side. It is fine. Then next is when we talk about ST graph. ST graph. Let's go here. ST graph. It should be a straight line. Here ST graph. So we may divide this portion up to this. So first segment it is this one, and let's give this name as a T0 or whatever T1. Fine. So negative, negative. First we identify shape. So a negative it is given, negative is given. So our shape of the ST graph it is convex. What is convex shape? This you can say inverse bowl is a convex shape. The next is initial velocity for this segment, segment number one. Segment number one, it is positive. It is positive. Segment number one, theta is positive because of what? Because of this velocity is positive. Velocity is positive for this region. For this region, velocity is positive. Therefore, here it is positive slope. So for this concave shape, it is not concave, it is convex. Convex shape, we need to identify theta is less than 0. So we know that it is very simple. From this, if I draw a line, so this theta is less than 90 degree. That means this side, left hand side will work. Left hand side should work. Left hand side should work. And another part is given. Another part is given here. It is positive. It is positive. So it is starting from x0. Starting from x0, it goes up. It goes up, right? And then it should move in the downward direction. It should move in the downward direction. It goes like that. It goes like that. We identified shapes. We identified shapes for that. So t0 direction of the velocity, the direction changes from the displacement. See here, there is a velocity become negative. Here in this case, velocity become negative. So from this negative direction, the remaining slope, it is theta greater than 90 degree. Theta greater than 90 degree. So it works like that. Let's see the drawings. So here AT graph, here it is minus acceleration A0. Then in VT graph, if A is constant, This line should be slope. This line should be slope. A is negative, B is positive, right? So V decreases. Like that, it goes up to T0. Then in next case, what we need to check? In the next case, we need to check. See, in the case if x is equal to 0, then this will be drawing. Here it is x0. So in the next case, what is given? So we need to check first acceleration. Acceleration, it is negative. That means shape is concave, not concave, convex. This is the shape. This is the shape. And second is we need to check initially here u is negative and acceleration. Sorry, u is negative. That means slope is negative. Therefore, theta should be greater than. It is not negative. U is positive. U is positive. For the first case, u is positive. So slope theta should be less than 90 degree. So here this theta is less than 90 degree. At t0, it reaches to maximum point, and then here u become minus u negative, and therefore slope theta should be greater than 90 degree. Slope should be greater than 90 degree, and here this is the case. See here, this slope is theta is greater than 90 degree. So this is the solution. Maybe little bit difficult at initial phase, but once you start understanding, that it won't be difficult for you. Let's have one more example of similar kind. If a body has a constant acceleration is constant. Initial u0 is negative, then x0 is positive, and then acceleration is also positive, a0. Fine. So now let's again draw here our lovely acceleration versus time graph, and acceleration is given positive. Can we draw positive acceleration? So this is our positive acceleration is constant. Second is that v velocity versus time graph. If this is the constant velocity graph should have inclined line. Should have inclined line. Right? If it is first is straight line, second line should be inclined line in the VT graph. So here u is negative. So here somewhere below this line, here somewhere, say for example, this is negative u0, right? Negative u0. So we have here negative u0, and positive acceleration. So we know that because of this too, what happened? Negative velocity decreases. That means it goes upward. See, whenever you see positive a, line is going upward, and whenever you see negative a, line is going towards downside. If you remember this two, it will work always. So here it again crosses the direction. It crossing the direction. Fine. Then third graph, when we talk about third graph, s versus t, s versus t, s versus t. So here at initially u is negative, or not u, just x0 is positive, x0 is positive, so it is starting from this point. Now what we need to check? We need to check first acceleration is positive, so shape is concave, and second is here u is negative. So slope should be negative, theta should be greater than 90. Theta should be greater than 90. Let's check theta. For this case, if I draw this is less than 90, it won't work. In the opposite side, if you go, theta is greater than 90. So this side curve should work. This side curve should work. This side curve should work. So curve should be like that, starting from somewhere in this case, and then may go like that. Let's see how it works. So AT graph U0 is negative. This is given for ST graph. We already checked. A is positive shape, negative velocity. That already checked, right? So I'm not repeating this all. So here acceleration it is given positive, so it is on the positive side. Acceleration is positive. Then negative acceleration, it goes like that. If it is straight line, that should be a inclined line. Negative u and positive acceleration. That means u decreases, right, in the opposite direction. So it goes on the opposite direction. Then next, if you want to just identify shape, A is positive, so it is con concave, concave, concave. And just we need to just move this direction on the initial u is negative. That means it should be theta is must be greater than 90 degree, and therefore this is the x0 starting with this. So this is the graph. Right? See, this is some extra bifurcation is also given if you want. At t is equal to t0, at t is equal to t0, at this position, talking about this position, right, x increases in the negative direction, and t is equal to t0 onwards, x increases in the positive direction. You can have extra material for your understanding on this. Let's have one more example of similar kind. I think this time you should pause the video and you should solve by yourself. What is given? If a body has constant acceleration, again it is given acceleration is constant, u0 means u0 negative, x0 is positive, and a is again negative. Wow. So let's do first a is constant and negative and negative. That means what? It should be below this line, negative as well. Then if you want to draw velocity versus time graph, if this graph is straight line, velocity versus time should be inclined line. It should be inclined line. So here velocity u is negative, u is negative, u is negative. So here it should be negative u0, and acceleration is also negative. See, both are negative. U is negative, acceleration is negative. That means velocity increases in the negative direction. Always simply, if it is minus a, go in the downward direction. If it is plus a, go in upward direction. That is simple logic we need to understand. So this is what we got it. Wow. Then we need to go with another graph, S versus T graph. S versus T graph. So you need to identify what two things. One is if negative acceleration graph is convex, like that. It is graph is like that. And second is that if it is minus u is given, that means theta should be greater than 90 degree. Theta should be greater than 90 degree. Let's check. If this is the theta, this is the theta we wanted to check. Is it greater than 90 degree? Yes, not less. It is greater than 90 degree. So only this much will work. So it is starting from where x0 is positive, so x is 0. And it is going like that. Wow. Let's check. Let's erase all the things and let's check. So initial position is given u is negative, acceleration is negative, both are negative. Fine. The next is graph, AT graph, u is positive, acceleration is negative. So v is linearly decreasing with positive direction. V is linearly decreasing. The positive direction may not require even. It is by default. Right. So in the ST graph, minus a is convex shape. Minus a represent convex shape, and the velocity negative represent theta should be negative greater than 90 degree. Slope should be negative. So it is that minus a. We already checked. This is minus a. Then going in downward direction, you compare with the previous one we did. This is with x is equal to 0 if it is, but here it is x is going up, right? So we already checked this. We already checked this. I think you must have compared this result with your result. You are must be having similar result for you also. One more example. Example number 11. A body is projected vertically upward with initial velocity is given u. U is initial velocity. Take the projection point to be origin. That means starting with x is equal to 0 from the projection point and upward direction as a positive. Draw position versus time graph, velocity versus time graph, acceleration versus time graph. So which graph we should start first? Sir, acceleration graph. We always should start with acceleration graph. From that conversion is very easy. Let's start. So when a body moves vertically, we know that it is always subjected to gravitational, and for that when body moves upward direction, acceleration is negative. Acceleration is negative. The body moves in upward direction, acceleration is always negative. We know that, right? We already studied this for the vertical movement of a body. So initial it is having u, it is a positive, and acceleration is having negative. Fine. So now what we need to find out the first. So for that we already have first knowledge that in the case of acceleration versus t graph, acceleration is minus g, acceleration is minus g. So here our solution is like that. Here it is minus g, right? Then what next? AT and VT graph, AT and VT graph. If it is t, it is constant. So for that graph, it is linear. It should be linear for velocity versus time. When you talk about velocity versus time, graph should be linear. Graph should be linear. Graph should be linear. So A is minus C, V is equal to linearly. It is linearly decreasing because V is positive, A is negative. V is positive, A is negative. Therefore, it is decreasing linearly. V is positive, starting with U, and it should decrease linearly like that. Then what next? Then what next? Next is ST graph. ST graph. So we can check minus A minus acceleration is give convex shape, means this shape. This is the shape. Then we need to find velocity. Initial velocity is positive. Initial velocity is positive. So therefore, slope should be positive. Slope should be positive. Let's check positive slope. Which one is positive? Which one is positive? If we just take this theta greater than 90, no, it is negative. If we take opposite side, opposite side, opposite side, opposite side, and this theta, yes, it is less than 90, less than 90. So this slope is positive. This slope is positive. This slope is positive. So we need this side only. We need this side only. We need this side. Wow. It may go away. It may go on also. It may go on. So here, if you grow with ST graph, starting with initial u, initial graph, it is like that. And that if this is the graph, then it should go in this manner only. In this manner only. You will see how it works. How it works. Right. So here, this is negative g, negative g. Then u is starting from this position. U is starting from this position, inclined line. This all the equations we will study in the upcoming chapter. And then maximum u square by 2g. That was not. We just focusing on shape. So this is the shape we are talking about. The shape. It goes maximum and then it goes to downward direction. Right. So it is starting with origin. Starting with origin. So x is equal to 0. X is equal to 0. That was only the difference from our imagination and the actual.